I'd like to call this meeting to order. Good morning and welcome to the boardroom of the National Transportation Safety Board. I'm Christopher Hart, and it is my privilege to serve as chairman of the NTSB. Joining me are Vice Chairman Bella Denzar, Member Robert Sumwalt, and Member Earl Weiner. Today we meet in open session as required by the Government and the Sunshine Act to consider a report on the in-flight breakup of Scale Composites SpaceShipTwo during a test flight near Cone Dry Lake, California on October 31st, 2014. While the public is invited to observe the meeting here in this room or via webcast, only the board members and NTSB staff will participate in today's discussions. Tragically, the co-pilot died and the pilot suffered serious injuries as a result of the breakup. On behalf of my fellow board members and the entire NTSB staff, I would like to extend our sincerest condolences to the family of the co-pilot. I would also like to extend our wishes to the pilot and his family for a full and speedy recovery. We cannot undo what happened, but it is our hope that through this investigation, we will find ways to prevent such an accident from happening again, thereby helping to improve the safety of manned commercial spaceflight. These two test pilots took on an uncommon challenge, testing technologies for manned commercial spaceflight, which is still in its infancy. Human spaceflight is subject to unique hazards, and test pilots work in an environment in which unknown hazards might emerge at any time. In an environment in which it is common to encounter unknown hazards, it is of utmost importance to incorporate as much as possible of what is known, the lessons that have already been learned from other, more developed modes of transportation. The accident that we consider today involves SpaceShipTwo, a manned, rocket-powered suborbital vehicle that Scale Composites developed for Virgin Galactic. Our investigation was greatly aided by the abundance of data that was available, including cockpit video telemetry, and as our investigators will explain, in addition to incorporating information provided by the pilot, we were able to see the actions of flight crew members and learn with a high degree of certainty the events that resulted in the breakup. What we saw led us to explore the extent to which Scale Composites considered human factors in this launch. This morning we will hear from staff about the pilot training and procedures that were in place. We will also hear how human factors were considered in the design and manufacture of SpaceShipTwo. The test flight was subject to oversight by the Federal Aviation Administration. The FAA's oversight role in commercial space is different from its oversight role in aviation. For commercial space, the FAA does not certify the vehicle. It only certifies the launch, focusing mainly on public safety. Nonetheless, many of the safety issues that we will hear about today arose not from the novelty of a space launch test flight, but from human factors that were already known elsewhere in transportation. And although commercial space transportation is in a period of great innovation, the FAA does have a process for addressing human factors for experimental launches. We will ask today whether the FAA's procedures and oversight were effective and whether they can be improved upon. We will examine the process by which the FAA issued and subsequently renewed a launch permit to Scale Composites and the process by which the FAA granted waivers from human factors and software hazard analysis requirements in the renewal process. We will also inquire whether there could have been more extensive communication between Scale Composites and the FAA regarding these critical issues. The NTSB is not a regulator, and we have no power to require changes. We identify the causes of accidents in all modes of transportation and make safety recommendations, which, if acted upon, can help prevent recurrences. More than 80% of our recommendations are acted upon favorably, contributing to a high standard of transportation safety today and pointing toward even safer transportation tomorrow. It is our objective in this meeting to identify actions that the FAA and the industry can take to collaboratively improve the safety of commercial space transportation in the future. Now, Managing Director Tom Zoller will introduce the staff. Mr. Zoller.
Good morning, Mr. Chairman, Madam Vice Chairman, members of the board. I would ask those in the audience, if they have not already done so, please silence their personal electronic devices. In the event of an emergency, there are 3 emergency exits here, 2 to either side of the dais and 1 in the back in the rear entrance. And if necessary, there's an AED at the far wall in the lobby. Seated at the table this morning, starting on my right and working down, John DeLisi, Director, Office of Aviation Safety. Next to him, Lorenda Ward, the investigator in charge of this accident. Dr. Catherine Wilson, Human Performance Group Chairman. Mike Hoff, System Safety Group Chairman, and Captain David Lawrence, Operations Group Chairman. Behind Captain Lawrence is Jeff Marcus, Safety Recommendations. Next to him is Mike Bauer, Systems Group Chairman. Next is Jason Fedock, Survival Factors Group Chairman. Karen Stein, the report writer. Jim Ritter, Acting Director, Office of Research and Engineering. David Toshin, the General Counsel. And Sharon Bryson, the Acting Director of the Office of Communications. Behind Ms. Bryson is Rob Huntsberger, who is the Propulsion Group Chairman and also operating the visuals and the timer. Next is Clint Cruikshanks, the Structures Group Chairman. Jim Rodriguez, the Attorney Advisor from the Office of General Counsel. Dean Payne, who is the Data Group Chairman. And finally, John O'Callahan, Vehicle Performance Group Chairman. John DeLisi, the Director of the Office of Aviation Safety, will start with an opening statement.
Thank you. Good morning. Although this is the first time that the Office of Aviation Safety has investigated an accident involving a reusable suborbital rocket, we've been involved with commercial space transportation for over 25 years. In fact, the board conducted the investigation of a launch procedure anomaly involving a Pegasus expendable launch vehicle, which was deployed from a B-52 aircraft in 1993, and issued a special investigation report with probable cause and safety recommendations. AS staff has ensured that we remained prepared for a commercial space accident investigation by attending industry conferences, completing outreach with manufacturers, and participating in tabletop accident investigation exercises. I'd like to recognize retired NTSB investigator Bob Benson, as well as Joe Sedor, the chief of our Major Investigations Division, and Lorenda Ward, the IIC of this investigation, for their efforts to prepare us for an investigation like the one we'll be discussing today. Although SpaceShipTwo is a different type of vehicle, I'm pleased to report that our procedures and protocols proved to be effective during the investigation of this accident. As with all major investigations, we dispatched a GO team consisting of a board member as the spokesman, an investigator in charge, NTSB specialists to serve as group chairman. We named parties to the investigation, collected factual information, including the highly valuable cockpit video images, and prepared a docket of factual information which was released to the public today. We appreciate the participation and cooperation of the parties, as well as the respect they showed to our staff throughout the investigative process. While always a party to our investigations, the FAA's participation in a commercial space investigation is different than in an airline accident investigation. For example, during an airline accident investigation, we interface with the staff of the FAA's Office of Aviation Safety as we look at issues regarding the federal regulations for the certification of aircraft and their oversight of commercial air carriers. However, during this investigation, our technical interface was with the FAA's Office of Commercial Space Transportation as we examined the role it plays in protecting public safety during the launch of an experimental suborbital rocket. In conclusion, I'd like to thank our investigative team for taking on the challenges of this investigation and allowing us to promptly deliver this draft report less than 9 months after the accident. Thank you. Lorenda Ward will now give the IIC opening presentation.
Good morning, Chairman Har, Vice Chairman Denzar, and members of the board. On October 31st, 2014, at 10:07 local time, Scaled Composites SpaceShipTwo broke up 13 seconds into its fourth rocket-powered test flight and impacted terrain over an area 5 miles long near Cone Dry Lake, California. The pilot was seriously injured and the co-pilot was fatally injured. SpaceShipTwo was destroyed and no one on the ground was injured by the falling debris. Scale was operating the vehicle under an experimental permit issued by the FAA's Office of Commercial Space Transportation, or AST. The Office of Commercial Space Transportation was initially established as part of the Office of the Secretary of Transportation within the Department of Transportation and was transferred to the FAA in November of 1995. Among other things, AST protects public health and safety of property, the U.S. national security and foreign policy interests, and encourages, facilitates, and promotes the commercial space industry. As part of these responsibilities, AST issues licenses and experimental permits for commercial launches of orbital and suborbital rockets. Scaled Composites has developed both White Knight 2 and SpaceShipTwo for Virgin Galactic. White Knight 2 was the high-altitude launch platform for SpaceShipTwo. SpaceShipTwo was the reusable suborbital rocket. The design mission profile for SpaceShipTwo was for an air launch from White Knight 2, followed by the boost phase, during which SpaceShipTwo's rocket motor would propel the vehicle from a gliding flight attitude to an almost vertical attitude and accelerate from subsonic speeds through the transonic region to supersonic speeds. Then the rocket motor would cut off and the vehicle would coast to apogee. Afterwards, SpaceShipTwo would transition to the re-entry phase, which was to occur in a feathered configuration that would stabilize attitude and increase drag. Next would be the glide phase, after the vehicle had transitioned from a feathered to an unfeathered configuration. Then the mission profile would be completed with an unpowered landing. As mentioned earlier, the feather system was utilized to stabilize SpaceShipTwo's attitude and increase drag during re-entry into the Earth's atmosphere. This was done by rotating the feather flap assembly and twin tail booms from the vehicle's normal configuration up to 60 degrees. Before the feather flap assembly could move, it had to be unlocked. The feather lock handles were located on the center console and held in the locked or unlocked positions by small detents. The detents prevented the handles from moving under normal vibration. To move the handles, a slight side force to the right would allow the handles to move past the detents. To unlock the feather, the pilot moved the unlock handles downward to their mechanical stop. The feather is then extended by pulling two feather handles out. On the day of the accident, it took about 48 minutes for the mated pair to climb to an altitude of 46,400 feet where SpaceShipTwo was released. The investigation had numerous data sources for the accident flight, including ground-based cameras and cameras on both White Knight 2 and SpaceShipTwo. The video about to be shown will start with the screen split in thirds, with the upper left showing the ground-based camera video, the upper right showing White Knight 2's pylon camera video, and the bottom center of the screen showing SpaceShipTwo's boom camera video. Then each video would play individually, starting with the tail boom camera from SpaceShipTwo, then the ground-based video, then the pylon camera from White Knight 2. The videos are stopped before SpaceShipTwo breaks up. We'd like to take a moment to pause to see if anyone would like to leave the room before the video is shown. Telemetry data showed that the feather moved, even though we know from the cockpit image recording that neither pilot had deployed the feather. However, the cockpit video did show that the co-pilot had unlocked the feather just after 0.8 Mach. Per the test card, the co-pilot was to unlock the feather when SpaceShipTwo reached a speed of 1.4 Mach. This was to allow the vehicle time to transition through the transonic region. Since the feather was unlocked in the transonic region, aerodynamic and inertial loads imposed on the feather flap assembly overcame the feather actuators, and the feather extended uncommanded, causing the catastrophic structural failure. Range instrumentation radar located on Edwards Air Force Base tracked White Knight 2 with SpaceShipTwo attached, and SpaceShipTwo itself following its release from White Knight 2, until the impact of SpaceShipTwo's main oxidizer tank and wings with the ground. The telemetry data ended during the breakup. During the breakup sequence, the pilot was thrown from the vehicle while still restrained in his seat. During his descent to the ground, the pilot released himself from his seat and his parachute deployed automatically. The pilot's seat and parachute were found separately. The top middle of the slide shows where the left and right tail booms landed, and the cockpit and nose and the rocket motor were located towards the bottom left of the slide. Parties to the investigation were Scaled Composites, Virgin Galactic, the Federal Aviation Administration, and Butler Parachute Systems. I would like to acknowledge the parties for their professionalism, openness, responsiveness, and their willingness to trust our process. Their cooperation enabled us to complete this investigation within 9 months. The NTSB launched a GO team, and Chairman Hart was a board member on scene. The next 2 slides show all of the NTSB staff who participated in the investigation or supported the team. The investigation identified the following safety issues: a lack of human factors guidance for commercial space operators, the efficiency and timing of the pre-application process, the limited interactions between the FAA and applicants during the experimental permit evaluation process, missed opportunities during the FAA's evaluation of Scaled Composites hazard analysis and the waivers issued, the limited inspector familiarity with the commercial space operators, the need for improved emergency response planning, and a fully developed database for commercial space operators on mishaps lessons learned. Dr. Wilson and Mr. Hall's presentations will go into more detail on the human factors and system safety issues. This concludes my presentation, and Dr. Wilson is ready to begin hers.
Good morning. I will discuss human factors issues surrounding the flight crew and design of SpaceShipTwo, as well as organizational issues of the FAA's Office of Commercial Space Transportation. Before release from White Knight 2, the flight crew completed all required checklists, and the pilot briefed the task to be completed during the boost phase. About 8 seconds after release from White Knight 2, the co-pilot made the 0.8 Mach call-out as appropriate. About 2 seconds later, at a speed of 0.82 Mach, the co-pilot stated unlocking and then moved the feather lock handle to the unlocked position. Both pilots acknowledged a pitch-up of the vehicle, and then the cockpit image recording ended. I will now describe the sequence of events that should have occurred during the boost phase. Duties were divided between pilot and co-pilot. Each pilot memorized his task due to the dynamic nature of the boost portion of flight. After release from White Knight 2, the pilot was responsible for vehicle control and would command fire, to which the co-pilot was to ignite the rocket motor. At a speed of 0.8 Mach, the co-pilot was to verbally call the speed to alert the pilot to expect the transonic bobble. The transonic bobble is a nose-up and then a nose-down motion of the vehicle that occurs due to aerodynamic forces resulting from a shift in the center of lift and becoming supersonic. No physical action was required by either pilot. As the vehicle became supersonic, the pilot was to trim the horizontal stabilizers, and the co-pilot was to assist the pilot by verbalizing the stabilizer trim position. Finally, at 1.4 Mach, the co-pilot was to move the feather lock handle to the unlock position. Only the physical action was required. There was no required call-out of the speed. Preparation for PFO4 began in January 2014. To learn the procedures and ensure proficiency, Scaled took a three-pronged approach to training SpaceShipTwo pilots: the SpaceShipTwo simulator, the White Knight 2 aircraft, and the Extra 300 aerobatic airplane. The SpaceShipTwo simulator was a fixed-base, no-motion simulator that replicated the SpaceShipTwo cockpit layout. The simulator was used by the pilot and co-pilot to practice running through the test card and non-normal procedures, as well as to conduct full mission rehearsals with the entire mission team. SpaceShipTwo pilots also trained using White Knight 2, as its cockpit layout was designed similarly to the SpaceShipTwo cockpit, and in certain configurations, White Knight 2 had a similar flight path and descent profile as SpaceShipTwo, which simulated glide through touchdown. Finally, SpaceShipTwo pilots received aerobatics training in the Extra 300, which included G-tolerance and upset recovery training. Scaled required SpaceShipTwo pilots to complete at least 3 full mission rehearsals, 3 simulated approaches in White Knight 2, and 3 aerobatic training flights in the Extra 300 to prepare for SpaceShipTwo powered flight. In addition to training, Scaled performed several flight readiness reviews before PFO4. In addition to the test team reviewing the vehicle configuration and any changes for the flight, the intent of these meetings was to get management buy-in on the risks that the team had identified and to determine potential unidentified risks through the use of independent subject matter experts. Scaled also held a town hall meeting to provide the team the opportunity to ask unanswered questions and to discover unknown issues that could delay the remaining SpaceShipTwo program schedule. There were no items discussed at these meetings for PFO4 that were related to pilot procedures for the feather system. Stressors were present during the boost phase of flight that likely contributed to the co-pilot unlocking the feather prior to 1.4 Mach. As previously mentioned, the co-pilot memorized his 3 tasks to be accomplished during this phase: calling out 0.8 Mach, calling out the stabilizer position in degrees, and unlocking the feather at 1.4 Mach. In addition to recalling these tasks from memory, each of the tasks needed to be accomplished in a limited time frame, less than 26 seconds according to post-accident simulator tests. If the feather was not unlocked by 1.8 Mach, the flight was to be aborted. Scaled designed a caution message to illuminate on the center multifunctional display, along with an oral enunciation at 1.5 Mach as a reminder to the crew if the feather was not unlocked by that speed. Because of the importance of unlocking the feather before 1.8 Mach, the co-pilot might have been anxious to unlock the feather to avoid aborting the flight. Another stressor during the boost phase was the operational environment, specifically the vibration and loads experienced with the rocket motor ignited. The vibrations and loads experienced during powered flight were not replicated in the simulator, and the co-pilot had not flown SpaceShipTwo under power since powered Flight 1 in April 2013. Although the pilots received G-tolerance training prior to the flight, pilots were not required to perform any mission-related tasks other than to demonstrate vehicle control during this training. The lack of recent experience with powered flight vibration and loads could have increased the co-pilot's stress and thus his workload during a critical phase of flight. Scaled composites did not emphasize human factors in the design, operational procedures, simulator training, or hazard analysis for SpaceShipTwo. During the design of SpaceShipTwo, Scaled did not consider the possibility that a pilot would unlock the feather before 1.4 Mach, and as such, no safeguards were built into the feather system design to prevent this. Although SpaceShipTwo program personnel said they were aware that unlocking the feather during transonic flight would be catastrophic, there was no warning, caution, or limitation in the SpaceShipTwo pilot operating handbook or on the PFO4 test card that specified this risk. The only documented discussions about the loads on SpaceShipTwo's tail occurred more than 3 years before the accident in an email and a PowerPoint presentation. AST was also not informed of this hazard. In addition, human factors was not fully considered in SpaceShipTwo training, as the simulator did not replicate the vibration and loads, nor did pilots train wearing the same flight gear that they were expected to wear during actual flights in the vehicle. Finally, Scaled's hazard analysis did not consider pilot-induced hazards that could pose a risk to public safety. This area will be discussed more in Mr. Hoff's presentation. By not considering unlocking early in the boost phase as a potential cause of an uncommanded feather extension, Scaled missed opportunities to identify design and/or operational factors that could have mitigated the catastrophic consequences of this single human error. Although Scaled engineers reference some military standards and FAA circulars, because commercial spaceflight is an emerging industry, no human factors guidance currently exists specifically for commercial space operators. Staff has proposed recommendations in this area. According to federal regulations for commercial space transportation, a prospective applicant must consult with the FAA before submitting an experimental permit or mission license application to discuss the application process and possible issues relevant to the FAA's licensing or permitting decision. Scaled Composites began meeting with the FAA as a part of this process in March 2010. While Scaled fully complied with the pre-application consultation requirements, when the pre-application process began, SpaceShipTwo had been designed and manufactured, and the system safety analysis was well underway. At that point, it could have been difficult and costly for Scaled to make changes to SpaceShipTwo if the FAA had found inadequacies in Scaled's hazard analysis during the pre-application consultations. Staff has proposed a recommendation in this area. Scaled Composites submitted its experimental permit application for SpaceShipTwo in January 2012. AST's experimental permit evaluation team then had 120 days to perform a comprehensive review of the application, including asking for and receiving additional information from the applicant. Throughout this process, there was one point of contact between the FAA and Scaled. This was to reduce the burden on Scaled of having to interact with multiple individuals from the FAA during the project. In addition, questions from the AST evaluation team were filtered by management prior to being sent to Scaled because they did not pertain to public safety. As a result, technical information requested from the team was never received. AST staff indicated there was pressure to approve experimental permit applications within the 120-day review period, even though they believed the technical data was still needed to complete their review. Staff has proposed a recommendation in this area. On May 23, 2012, the FAA issued Scaled its initial experimental permit for SpaceShipTwo. Once the permit was approved and prior to launch operations beginning, the FAA assigned a safety inspector and an assistant safety inspector to each launch activity. The inspectors used a safety inspection plan to ensure compliance with federal regulations and the terms and conditions of the experimental permit. In addition, inspectors were supposed to verify that the representations made in the operator's experimental permit application were still accurate. Safety inspection plans were generally accomplished several days before a launch. Finally, safety inspectors were assigned to an individual launch operation and not specifically to an operator such as Scaled. Therefore, inspectors did not have adequate time to familiarize themselves with Scaled's training, procedures, and operations prior to conducting the safety inspection plan and could not perform a comprehensive review of Scaled or SpaceShipTwo. Staff has proposed a recommendation in this area. Thank you. Mr. Hoff will now discuss issues regarding Scaled Composites hazard analysis and the waivers issued by the FAA.
Good morning. As outlined in Section 43755, experimental permit applicants must perform an analysis that identifies hazards, including those resulting from human and software errors. For each identified hazard, the applicant must assess the risk to ensure it meets acceptable criteria, and if not, risk elimination or mitigation measures must be identified to reduce the risk to an acceptable level. The last step of this hazard analysis is to demonstrate that the risk elimination and mitigation measures achieve an acceptable reduction in risk through validation and verification.
Excuse me, Mr. Hoff, I'm not sure that we've clarified what this is Section 437 of.
Part 437, 43755 is the hazard analysis. requirement.
And that's in the Code of Federal Regulations, or I'm not sure we have identified where that came from.
Yes, Code of Federal Regulations.
And which section of the Code of Federal Regulations, do you know?
Part 437.
430, I see, okay, thank you.
An FAA advisory circular provides guidance to applicants on the hazard analysis requirements, including approaches to identifying and describing hazards, risk assessment, risk elimination or mitigation, and validation and verification. Regarding human error, the advisory circular states that a hazard analysis must address human errors including decision errors, such as using flight controls at the wrong time, and skill-based errors, such as improperly following a procedure. One of the hazards Scaled identified was uncommanded feather operation. Their analysis indicated this hazard would be catastrophic if it occurred during the boost phase of flight. To identify the potential feather conditions that could lead to this hazard, Scaled performed a fault tree analysis. This analysis assumed that the flight crew would be properly trained through simulator sessions and that the flight crew would follow established procedures. Because of these assumptions, the analysis only identified system failures or malfunctions occurring after the locks were normally released by the flight crew. Specifically, the analysis showed that after normal release of the feather locks, a failure involving both feather actuation systems would need to occur for it to move uncommanded. Because the probability of failure for this hazard met the risk criteria, Scaled determined that the feather system design was adequate. No mitigations were considered to prevent the flight crew from unlocking the feather locks early. In May 2013, Scaled was granted a renewal of the SpaceShipTwo experimental permit. However, FAA personnel's concerns led the FAA to re-examine Scaled's hazard analysis. FAA determined that the SpaceShipTwo hazard analysis did not fully comply with the human and software error requirements of the regulation. The FAA chose to waive those requirements from Scaled's permit and issued a waiver in July 2013. Scaled did not request the waiver, participate in the waiver writing or evaluation processes, or have an opportunity to comment on the waiver before it was issued, except to identify proprietary information. The waiver was extended when the permit was renewed in May 2014. According to the FAA, issuance of the waiver was based on mitigation measures, most of which were extracted from Scaled's experimental permit application. These included the training program, an incremental approach to flight testing, and the use of chase planes. Further, the permit's limited duration, the remoteness of the operating area, and the use of winged vehicle led the FAA to conclude that Scaled activities would not jeopardize the safety of the public or property. However, in its development of the waiver, the FAA did not verify that Scaled was in compliance with the mitigations cited in the waiver from regulatory requirements or validate whether those mitigations would adequately address human errors. Further, staff's investigation found that some FAA inspectors were unfamiliar with the details of the waiver, and all of the inspectors thought that Scaled had complied with the mitigations contained within the waiver. It is important for the FAA inspectors to ensure that a commercial space operator is implementing mitigations in a waiver to determine their effectiveness in ensuring public safety. Staff has proposed a recommendation to address this issue. This concludes my presentation, and staff is ready to answer questions.
Thank you for those excellent presentations. We will begin the question and answer session with Member Sumwalt.
Good morning. I want to thank the staff for doing a great job with a very complex investigation. As Mr. DeLisi pointed out, it was done in 9 months. And as Ms. Ward pointed out, I think the parties played a huge role in allowing the investigation to be done successfully and in a timely fashion. You know, as humans, we all commit mistakes, and I commit errors in my personal life all the time, and when I was flying, I made a lot of mistakes as well. Some were pretty darn serious, and some were errors that I never even noticed, but yet the errors had occurred. And I think the question we're all trying to answer here is, why did the co-pilot unlock the feather early? And I think that's a question that people have been pounding their heads trying to figure out for 9 months now. To put it in perspective, I was reading the interview summaries, and according to one of the scale test pilots, he said the accident co-pilot was, and I quote, as professional of a co-pilot as you could have, and was 100% prepared for the mission. He was always looking for ways to do things better. He knew the FAA regulations better. No one knew the FAA regulations better than him. No one was better at procedures than him. And I think that really puts in perspective that this was somebody that was really a professional and trying to do it the right way, and yet the error occurred. Some of the people that were interviewed, some of the test pilots that were interviewed, commented that the pilot workload was high right after launch. One test pilot commented that with respect to unlocking the feather prior to 1.4, it was difficult not to be late. It's a busy time, and personally, I would be late on it if my workload was high. He said, you've got to be on your game to get it right every time. So, Dr. Wilson, in your human factors expertise, I noted that 4 days before the accident, the co-pilot unlocked the feather late. He did it after 1.4, and I think they got the alerting in the cockpit, and he was debriefed on that. And given that that's prevalent in his mind, everyone knew the hazards associated with unlocking late. It would require an abort of the mission. So he had been debriefed on this 4 days prior to the accident. In your mind, do you believe that this recency of experience may have been a factor in his wanting to hurry up and get it done?
That was something that we considered, and we did talk to pilots that were involved in that simulator session and also the debrief following that simulator session. Nobody seemed to be overly concerned that the pilot had unlocked late. It was debriefed after the simulator session, but it was debriefed as any other debrief item, so there wasn't extra emphasis placed on that. We also know that the day prior to the accident, the co-pilot and pilot were in the simulator for an extended period of time, several hours, running through numerous simulations, running the test card, and in no time was the feather unlocked early or late during those sim sessions. So we felt confident that the late unlocking 4 days before the event did not contribute to the pilot's early unlocking on the accident flight.
Thank you. But pilot's interview did comment on the difficulty of getting it done due to workload. And I noticed that one of the things that I did notice in going through the docket was that Scale had added steps for the co-pilot in PF04. For example, in PF01, Powered Flight 1, they didn't even deploy the feather because of the short burn time of about 16 seconds, I think. But on PF02 and PF03, the only duties during the burn for the co-pilot were to feather unlock at, it was 1.2 on one flight and 1.3 on the next. So there was just one item, one memory item for that pilot to do, the co-pilot to do on those two flights. But finally, when we got to PF4, there were the three things that they had to do. He had to call Mach point 8. He had to call the stab trim, and that was in increments, right? For every degree of change that it changed, he had to call those out, right? It wasn't just a one-time thing. It was like 8 degrees, 9 degrees, 10 degrees. Is that correct?
Yes.
And then finally, at 1.4, unlock the feather. So my point is that in a high workload environment, Scaled actually increased the workload on PF04. And I think that each step that you add for a pilot to do, it adds complexity, and with the increased complexity comes the increased possibility of an error. So I'm out of time, and I'll come back in just a moment. Thank you.
Thank you, Member Sumwalt. Member Weiner.
Thank you. Mr. Hoff, I'd like to talk a little bit or discuss the hazard analysis. What did the hazard analysis for this kind of vehicle consist of?
Consisted of identifying and characterizing hazards, coming up with mitigations for those hazards, and then verifying and validating the mitigations.
And at what point in the design process was this hazard analysis done?
I believe Scale started their system safety assessment in about 2006.
And how far along in the design process was the vehicle at that point?
I'd like to defer that. I'm not sure.
I guess the question is really more along the line of, was the hazard analysis, particularly the hazard analysis that related to the human factors, done early enough so that had problems been found, that there was plenty of time to take care of it without holding up the process?
I believe so.
So were human factor requirements put into the early design requirements?
Scale did consider human error in their fault tree analysis. They considered it as the flight crew, let's see here. They considered the possibility of human error for the flight crew responding to failures or functional failures that they identified in their analysis.
So they considered the possibility of flight crew error in their responses to system anomalies and so forth?
Correct, system functional failures.
Did their analysis, though, consider, well, I think that was presented that their analysis did not consider the fact that the pilot might have done the wrong thing with regard to the feather system unlocking. Is that correct?
Well, their hazard analysis did not consider pilot-induced hazards.
But their analysis did consider that if the system was unlocked at the lower Mach numbers, that you could have a catastrophic loss of the vehicle?
Their fault tree analysis for the feather system considered uncommanded feather as a catastrophic hazard. For that particular hazard, they considered that the flight crew had normally released the locks, and the failures would be system failures that would cause the uncommanded hazard.
So they were not focused then on the flight crew, the pilot or co-pilot in this case, taking the wrong action?
That's correct.
In the design process, the design assurance process, so they have that functional hazard assessment. They had a fault tree analysis, is that correct?
Yes, functional hazard analysis and a fault tree analysis.
And just make a few comments about what does a fault tree analysis show?
It's a systematic deductive analysis, top-down, identifying failure modes that could cause the top hazard.
And the functional hazard assessment, by the same token?
The functional hazard assessment is identifying vehicle functions and failures of the systems.
And ordinarily, these are done in the design process at a point that can be, that if you find something that you don't like, you can recover from it.
Yeah, advisory circular guidance said iterative process should be done very early on in the design phase, throughout the entire process of designing and developing the vehicle.
Okay, so the fault tree is a top-down analysis, and the functional hazard assessment is kind of a bottom-up analysis. Is that?
Well, functional hazard analysis is the identification of the hazards, looking at the vehicle functions and the systems, such as uncommanded feather operation.
Mm-hmm. And they got waivers on the human factors assessment as well as the software assessment, is that correct?
Correct.
And these were waivers that were not asked for?
Scale did not request the waiver, no.
what sort of what sort of educational background or professional background is required for human factors analysis?
I defer to you, Dr. Wilson.
Could you repeat the question?
We had a waiver on the human factors analysis and the software analysis. I'm just curious about, in the human factors analysis, what kind of, let's say, educational background, professional background should have been available in terms of the human factors analysis? In other words, everybody thinks they're a human factors analyst because they're human, but in fact, more is required than simply that.
From our interviews, we found that there was not a person on AST staff that had a specific human factors background. People may have had a class in human factors, but not a specific degree in human factors. So it could have been difficult for them to identify what was needed for the human factors hazard analysis.
And the human factors analysis, just to finish this off, is more than simply the ergonomics.
Correct.
Thank you.
Thank you, Member Wenger. Vice Chairman Denzar.
I was very impressed with the thorough and efficient investigation and report that the staff conducted with the cooperation of the parties. So no one wants to impede innovation, but our priority is to ensure that safety is served. And the report proposes several recommendations to the FAA, specifically to AST. Would you explain why it's important to safety for the FAA and FAA inspectors to be aligned with individual operators who are applying for an experimental permit or a launch license?
The genesis of that particular recommendation comes from a philosophy that's familiar with the FAA right now. During manufacturer certification process of specific aircraft, the FAA assigns flight test engineers and flight test pilots specifically to that vehicle for oversight of that particular vehicle. In the process of this investigation, we found that several of the inspectors were unfamiliar with the vehicle. They were unfamiliar with the pilot operating handbook and the procedures that were used by the SS2 pilots. So the process of defining inspectors and assigning them specific to the vehicle would provide a better comprehensive knowledge of the vehicle, the history of the vehicle, and consistency throughout. And this is modeled after the process that's used in aviation for FAA.
Thank you, Captain Lawrence. And some people in attendance or watching may not be familiar with the way the NTSB issues recommendations, safety recommendations, to whom or why we issue certain recommendations, and whether and when an action is taken that we no longer issue that safety recommendation. So could someone explain the actions to increase safety that Scaled Composites and Virgin Galactic, as separate organizations, have taken since the accident, and hence why we no longer are issuing them recommendations?
I'll take that one. Scaled Composite, right after the accident, actually grounded their fleet and went back and did a flight readiness review of all their airplanes to make sure they were ready to return to flight. They also looked at their parachute training. They improved that. And Mr. Fetta can go into more detail about what was done at Scaled. They also identified that they did not have the human factors expertise, and looking at that to add into their system safety analysis. As far as Virgin Galactic, they did look at the design of the vehicle, and they have added an inhibitor so that the feather locks cannot be unlocked at a certain condition. They have also chosen to do a challenge and response and incorporate crew resource management for their pilots. I think that's good.
Thank you, Ms. Ward. And I may come back with a question for Mr. Fedock later about parachutes. But first, could you describe the relationship between Scaled and Virgin Galactic at the time of the accident and now, just so that we and the public can understand that?
Yes, at the time of the accident, Scaled Composite was actually the one that had the experimental permit with the FAA. They were the ones who were doing the developmental and flight testing of the SpaceShipTwo. They had transitioned White Knight to Virgin Galactic, so there was a Virgin Galactic pilot on board the day of the accident flight. The intent was to transition SpaceShipTwo to Virgin Galactic at the end of the year, around December 2014. After the accident, Virgin Galactic assumed the developmental and testing of serial number 2 of SpaceShipTwo, and so now the spaceship company will be building the second vehicle. Scaled Composite does have some contractual relationships with Virgin Galactic, so they are still assisting in case there are questions in regards to the vehicles.
Thank you. Well, I'm glad to hear about the actions that are being taken, and my time's almost up, but I'll proceed on the next round. Thank you, Chairman.
Thank you. I'd like to ask some questions about how realistic the simulation is. So, for example, what do the two pilots wear in an actual flight? Is it a spacesuit type thing? Is it flight suit, helmet, visor, gloves? What do they wear when they're actually flying?
They wear a flight suit that is like a jumpsuit, a helmet, visor, oxygen mask, and gloves.
And how much of that are they wearing while they're in the simulator, just to have the realism of just how they fit in the seat and how they flick switches with gloves and what they can see through their visor and that sort of thing?
Based on our interviews, they do not don the full gear when they're doing simulation work.
So they do it in shirt sleeves? I mean, just in regular, not necessarily flight clothes? Or do we know?
We don't know
Okay.
exactly, but we do know that they weren't using the gear that was replicated in the actual vehicle during flight.
There was also reference of the G loading. There's horizontal Gs, there's vertical Gs, and also vibration. So I assume that the simulator couldn't replicate any of those three either.
That's correct.
What do we know about how NASA replicates vertical Gs or horizontal Gs when they're training their astronauts? Because they go through some pretty serious Gs too.
Right. It's interesting because several of the AST evaluators that we interviewed in response to their evaluation of the permit had former NASA experience, and several of them had work in the NASA simulation as well. They do have the capability of doing motion simulation, but the evaluators we talked to with the experience with the NASA sim and the Space Shuttle simulator said there's just really no way that you can replicate in a full motion simulator the boost phase and the acceleration phase when the rocket's ignited.
And just to provide some context, could you give me an idea of the range of horizontal and vertical Gs that would be experienced during these 13 seconds after the launch? Do you have any sense of that?
I don't have that information now.
I think we know from the data that it's around 2.5. Mr. Callahan can correct me.
Horizontal or vertical?
I think they were both around that. John?
Yeah, I have that information. Just let me take a look here. So the longitudinal load factor would be close to 2.5, and the vertical load factor could be as high as about 4.
Okay, thank you. Let me ask about the reference that AST was not warned about the potentially catastrophic nature of a premature unlock. And I'm just wondering, maybe this is actually a legal question, maybe I'm asking the wrong people, but I'm just wondering, is there anything in the process, since AST is looking at public safety, that's their mandate, is to look at public safety, but not to certificate the vehicle as they would in aviation. The reference that AST was not notified of this, were they required to be notified of this? Was there anything in the structure of this process that would have required them to be notified of the potentially catastrophic nature of a premature unlock? If that's really a legal question, I don't really want to, maybe I could ask counsel, but...
Well, there was no requirement that said they had to be warned of that specific failure, but as Mr. Hoff mentioned, in the fault tree analysis, they assumed failures would only occur by the pilots after a system failure, and then a pilot's inappropriate response to that. So while no legal requirement, Scale did not consider that the pilot would induce that kind of failure.
So the assumption was that if there's a chain of events that went the wrong way, it would not be pilot-induced, it would be system-induced.
Right.
Okay. I'm concerned about this granting of a waiver that wasn't requested. Maybe somebody can walk me through that process. Why is a waiver granted when it wasn't even requested? Does anybody have any thoughts on that?
See, after the renewal of the first permit, AST did another evaluation or a review of Scaled hazard analysis, and based upon that review, they identified that Scaled had not met the specific requirements of the Part 43755 hazard analysis regulations. And then based on that, AST management determined that they should issue a waiver to Scaled, and Scaled had not requested that.
Okay, my time is about up, but before I go, I would like to follow on what Member Sumwalt said about congratulating the staff for quite an amazing job done in a short period of time, and of course with the cooperation of the parties, but that was quite a feat that you accomplished, because I know you had mountains of data, which is good news and bad news, but you had mountains of data, you went through that, and kudos to the staff for what you did and the amazing job that you did in such a short time. We will now go to the second round of questions. Member Sumwalt.
Well, thanks. While we're congratulating people, Mr. Chairman, when a board member goes to an accident scene, you always are nice in the board meeting and thank us for our service. So I want to thank you for going to this accident and your service there. I know it was tough, and thank you. So in the last round, I talked about how I felt that Scaled, well, not just I felt, but Scaled had added steps in PF04 for the pilot, for the co-pilot. And I think in PF02, they found that beginning in 02, they found that it was a good technique for the co-pilot to call Mach 0.80 to prepare the other pilot for the transonic bobble. And they thought it was such a good idea that they said, let's go ahead and incorporate that as a procedure. And that, I'm sure that is a good procedure, but technology could help us out here. We've already got a high workload period where there's a lot going on. There's G's, there's vibrations, and a lot going on. And so why would you want to increase workload in an already workload-intensive phase of flight? A few weeks ago, 2 months ago, I went and flew the Airbus's latest model, the A350, and a computer called out on takeoff roll V1. And pilots used to make that call out late, which would cause problems. So here, technology comes to the rescue. Something like that. Scaled is certainly a very technologically advanced company. Technology could have been used to reduce some of that workload during a high workload period of time instead of increasing it. What I want to know, Dr. Wilson, you said in your statement there that the co-pilot may have been anxious to unlock. Do you think, is it possible that there was so much emphasis within the company to make sure that they unlocked at 1.4 and less of an emphasis on the consequences, the deadly consequences, catastrophic consequences of unlocking early?
We definitely saw from our interviews and also from the documentation that we reviewed that there was more of an emphasis to ensure that the feathers were unlocked prior to 1.8 Mach because of the risk of them not locking at apogee could result in the feather not deploying for the re-entry, and that they knew could be catastrophic. So there was definitely more of an emphasis on that. We only have 2 documented evidence that shows that there was an email that talked about the loads on the tail and also a PowerPoint presentation, but really in neither of those situations was it emphasized that unlocking early would be catastrophic.
So I want to probe on that. We have a statement in the draft report that discusses Scale's failure to fully inform the pilots of the risk of unlocking the feather system early. I see conflicting information on that. I see it's sort of hard for me to tell exactly what the deal is here. Like on page 21 of the Human Performance Group Chairman's factual report, it says there was no documentation in the POH, the Pilot's Operating Handbook, that discussed the risk of unlocking the feather before Mach 1.4. But according to interviews, pilots were aware of the risk of unlocking the feather during the transonic phase of the flight. Then I go to page 50 of the Ops Group Chairman's Factual Report, and it says, according to multiple interviews with scaled engineers, there was a recognized risk to unlocking the feather prior to 1.4 Mach, because unlocking the feather when the tails were generating a large lift could overpower the feather actuators. The SS-2 accident pilots knew the feather should not be unlocked prior to Mach 1.4, but he could not, and this was the accident pilot himself, the surviving pilot, but he could not remember if that information was covered in the design review or informal discussions. And he said he believed it was common knowledge that the feather locks were required in the transonic region. Other scale composites and Virgin Galactic pilots stated they were also aware of the hazards associated with unlocking the feathers during the early boost. Says the accident pilot could not recall a discussion of unlocking the feather in the transonic region as being hazardous or catastrophic. The pilot further stated that he and the other pilots were aware that the locks were required to be locked in the transonic regime. He said he knew that if the feather locks were not locked, it could be hazardous or catastrophic, but he did not remember discussing it in the analysis. So based on those things that I just read, why is it that staff believes that Scaled failed to fully inform the pilots of the risk of unlocking the feather system early? I mean, it's right there in the interview summaries.
I believe what we discovered during the interviews, as you pointed out, that there was a knowledge, but it was a conversational knowledge. It was not institutionalized in any formal documents or guidance material. For instance, the Pilot Operating Handbook, as this board, I'm sure, is very aware of, is the repository of the operational information that pilots use. And this information includes the normal checklist, the emergency procedures checklist, but it also includes warnings, cautions, and limitations on the vehicle itself. The review of the Pilot Operating Handbook had no reference to the catastrophic consequences of the early unlocking, and it's not unique that it wouldn't have that, because there was also a reference in the handbook about the feather unlocking or the feather actuation while mated, and there was a warning there that said that could be catastrophic as well. So staff believes that the logical place to institutionalize some type of single pilot or single failure action that could cause a catastrophic failure would be the Pilot Operating Handbook, because that's the reference that the pilots would use on a continual basis to operate the vehicle.
Thank you so much. Thank you.
Thank you, Member Summerall. Member Weiner.
I'd like to go back, excuse me, to some of the design criteria. Were there requirements in the FARs or in Part 14 CFR? Because you mentioned 14 CFR 437.55, and what do those requirements consist of?
For the hazard analysis specifically, it's Part 437.29, which states that you have to do a hazard analysis per Part 4 or Section 437.55 and provide the results of that analysis to the FAA. Section 437.55 has the steps or procedures to conduct the hazard analysis, which identify the hazards, classify the hazards, come up with mitigations, and also perform verification and analysis of the mitigations.
So what was the requirement in terms of a single event causing a catastrophic outcome? Was there a probabilistic value to that?
There was not. Section 437.55 requires that you must identify hazards, including human error, and basically it requires you to do it qualitatively, not quantitatively.
But there was an advisory circular with that company that, is that, am I correct?
I'm sorry, could you repeat that?
Well, there was an advisory circular 43755-1.
That's correct.
And that advisory circular did have numerical requirements in it, or at least advisory material?
It did provide a definition of extremely remote, which is 10 to the minus 6.
10 to the minus 6. Just out of curiosity, what, by comparison, is a requirement, similar requirement for a certified vehicle, certified aircraft?
10 to the 9th.
10 to the minus 9th. The report talked about test readiness reviews. What does a test readiness review consist of?
They reviewed outstanding issues with the vehicle. There was a test readiness review covered, I believe, the ground issues from the ground vehicles and ground operations, and then they also had the flight readiness reviews, which covered any issues that were related to issues in flight. Typically, though, when we reviewed, especially leading up to Powered Flight 4, it dealt more with the systems and the structure versus pilot procedures.
So there were two flight readiness reviews or two reviews?
There was test readiness reviews and flight readiness reviews.
So what is the so-called town hall meeting?
When the flight was delayed, just prior to Powered Flight 4, the company held a town hall meeting, which allowed members of the team to come in and ask any unanswered questions that were related to the flight, and also to discuss any other issues that may come up that could delay the SpaceShipTwo schedule.
So this was a voluntary meeting?
Right, and it was more impromptu. This wasn't a regularly scheduled meeting as a part of the powered flight test procedures or process.
All right, thank you. I'll yield the remainder of my time.
Thank you, Member Weiner. Vice Chairman Denzar.
Thank you, Chairman. I appreciate the FAA's role ensuring safety, and I understand the challenges they face in commercial space. So my question is, did you find that FAA staff have enough of the technical data they need, or the right kind of technical data to do safety assessments? And if not, why not?
Well, I can address the experience level from the AST staff that we did do interviews for the evaluators that looked at the permit application during that process. Most of those evaluators had space shuttle and ISS experience as well, and brought that expertise to AST.
And were they able to obtain sufficient data in their interactions with, for example, Scaled or Virgin Galactic to make the safety assessments?
Well, that was one of the problems that they voiced to us, was that during the permit evaluation process and the technical review of the vehicle and the whole process, they had requested information directly to Scaled to obtain information based on questions that they would have. However, management at AST would filter or scrub, is the term that some of the evaluators told us, some of those questions as it related to simply protecting the public. So some of the questions and some of the inquiries from AST evaluators and staff never made it to Scaled for proper identification and answers.
Thank you, Captain Lawrence. But it sounds like the information's available. It's just maybe a communication issue.
Yeah, I should point out that in interviews with Scaled, they were very open about their role, and also receptive to answering any questions that AST could have posed to them. So I think the filtration came from the AST side down. Scaled was welcome to answer any questions about the vehicle in the process.
Thank you, Captain Lawrence. That's very helpful. So the draft report also proposes some recommendations to the Commercial Space Federation. But as I understand it, not everyone is a member of the Commercial Space Federation. So I assume we're not intending to leave out any companies on this discussion of standards, and we want all the different companies involved in this field to be involved. Could you elaborate on that and discuss why we're only issuing it to the Commercial Space Federation?
Actually, it's a joint recommendation to both the FAA and the Commercial Spaceflight Federation. The reason that the Commercial Spaceflight Federation was chosen is they happen to be an industry organization that have over 60 members. Granted, not all commercial space organizations are part of it, but we do encourage both the FAA and the Commercial Spaceflight Federation to invite them to participate.
Great. So we're using them as one means, but the recommendation and the invitation to take part in the guidance crafting is open to everyone. Is that correct?
Correct.
Thank you. And I yield my last 1 minute of time.
Thank you, Vice Chairman. I have some questions about it. It's a little bit surprising that if this premature action could be catastrophic to the vehicle, that there wasn't stronger emphasis on that fact in lots of places, including, as Captain Lawrence said, in the Pilot Operating Handbook. So I'm just wondering, how robust was that analysis that anything before 1.4 could be a problem? I know that in previous launches it was 1.2 and then it was 1.3. Was that on the basis of wind tunnel or calculational, or just how robust was that? Was it a almost certainly going to be a problem, or maybe be a problem, or just how robust was that analysis about the need to wait until 1.4?
Mr. Callahan can answer that.
Scaled computed the feather moments acting on the vehicle on the basis of computational fluid dynamic studies with computers, and then verified some of the results through flight tests, both the glide flight tests that had occurred, many of them, and then the 3 previous powered flights. On the powered flights, they had strain gauge instrumentation in various parts of the vehicle that could be used to compare the measured loads with the CFD loads, and it turns out that there was a pretty good correlation. And after the fact, we verified through computation with that model that, in fact, the feather moments were sufficient to overcome the actuators and fold the vehicle up, as was observed on the video.
Thank you. And was there a reference to an event where there was in a previous flight, that once the locks were unlocked, that there was a slight movement out of lock? I'm trying to remember what that reference was about. There was a previous event that referred to going through a transonic range, I think, where there was a movement from brief movement from lock to unlock. Am I remembering that correctly?
That's correct. That occurred on powered flight 02. As the vehicle goes through the transonic region 2 times, once while it's accelerating with the rocket motor on, and then when the rocket motor shuts off, it decelerates back through the transonic region. And in terms of moment coefficients, you have the same high coefficients wanting to move the feather up. On powered flight 02, this occurred, the deceleration through this region occurred at a relatively lower altitude and at a deliberately tested point to explore the limits of the feather operating envelope. So it was deliberately flown very close to the edge of the ability of the actuators to keep the feather down. And in fact, they got a slight movement of about 0.8 degrees for less than half a second.
Okay, thank you. That's all from me. Do we have any further questions from any of the members? Member Sumwall.
Yes, thank you. I'm not sure exactly who it will be directed to. I'll figure that out in just a moment. So Scaled understood very well that in the transonic region, if the feather was not locked, the aerodynamic loads would push the the feather up, those forces would exceed the ability of the actuators to hold them down. So therefore, they had to remain locked during that transonic region, right? So they knew that and understood that very well. So the lock had to remain in place through the transonic region to keep the tail down, the feather down. What was Scale's mitigation for making sure that those locks did not get unlocked early? Didn't they say that, quote, we rely on the pilots to do it correctly? Is that correct?
That's correct.
So they put all their eggs in the basket of the pilots doing it correctly, right?
Yes.
So that's a single point failure. If the pilot does it wrong, or the co-pilot does it wrong, then it will have very bad results, catastrophic results, in fact.
Yes.
And that was known. The catastrophic effect was known. So would a single point, and I guess, Mr. Hoff, this is for you, would a single point mechanical failure with catastrophic consequences be acceptable?
It would not.
It would not. So why would a single point human failure be acceptable? And it really should not be acceptable. The fact is, if you put all of your eggs in the basket of a human to do it correctly, and I don't mean this flippantly, because I've made plenty of mistakes, but humans will screw up anything if you give them enough opportunity. And I don't mean that in any disrespect to the crew, but the fact is a mistake was made here. But the mistake is oftentimes a symptom of a flawed system. And so it's important to anticipate the errors and design an error-tolerant system. You don't go into it believing that, oh, no one will never make a mistake. You design it knowing and believing that the error will occur, and then design the error, the system to trap or mitigate that error. Here the error occurred, the catastrophic error occurred on the 4th powered flight. So it was not an error that had unimaginable probability of occurring. How many times had they deployed the feather in the glide flights, the cold flows or any of that? The feather had been unlocked on how many flights approximately? Probably 6 or 8 or a dozen?
I think it's 9.
9 plus 2 other powered flights where it was unlocked, because it was not unlocked at powered flight 1. So 9 plus 2, 11. This happened on the 12th time that Scale was unlocking the feather.
I went to 9 total times. Sorry.
9 total times,
Right.
and that even makes it even more compelling. So my point is that a single point human failure has to be anticipated, and then the system has to be designed to compensate for that error. In fact, if you look at the safety order of precedence, Scale used the very lowest form of mitigation, because the system safety order of precedence says the first thing that you should do, the highest mitigation, would be that you design or engineer such that the error will not occur. And then the next order down is that you would then put guards in the system, which they have now done. They guard it so that this error can't occur. There's an interlock in there that it won't allow it to unlock until you get to, I think, 1.4. Then you put warnings, which we're hearing Captain Lawrence say there were no warnings in the POH. And what they really relied on was the lowest measure, which is procedures and training. So I think that says a lot right there. I've got 23 seconds. Is it fair to say that there was a silo mentality within the FAA AST? Is that a fair statement? That everything had to flow through one person, and sometimes that information would flow in, but it wouldn't flow back. That's what I'm reading in the report. Did I characterize that over-characterization, but is that generally correct?
Yes, all information from staff had to flow through management, and then from management, one point of contact through to Scaled.
And the people with the technical knowledge within the FAA complained that by the time their answers got answered, they were basically so watered down that their concerns weren't accurately relayed. Do you agree with that? Is that correct?
Yes, there seemed to be a disconnect between the information that staff wanted, the technical information, and management, which believed that those questions were not relevant to public safety.
Thank you, and I've got one last question, and that is that in the report, it states from the FAA AST evaluator added that there was, quote, a lot of pressure, political pressure, end of quote, to issue experimental permits. And when I read that, that worries me. What do we mean by pressure, political pressure? What is this? Where's this pressure coming from? They had to get these permits done in 120 days, right? They needed more time, is what some of them were saying, right? So, we don't want to slow government. We all hear about the bureaucracy and that we can't get things out of the government. We hear that. As citizens, we hear that. But what, if they needed more time, where was this pressure coming from? I remember back 20 years ago to the ValueJet accident, 96, 19 years ago, where there was supposedly an administration push to how lots of new entrant carriers in there, and that ValueJet was running and they pressure to allow them to do things. Was there that sort of political pressure within AST?
I just want to step back for a second and say that, they did have a 120-day requirement. One of the things they helped to meet that 120-day requirement is they had the pre-application process. And so what that would do is they would work with the applicant, and then they could decide whether or not the application was complete enough, and then it could move forward. So that could help with that 120 days. If at the 120-day mark, there's also a tolling process that can be put in place, so it actually could have an extension where they could get additional information.
Okay, thanks. How about this political pressure? Where's that coming from? Is that just one person's opinion? We must have felt that it was significant because it ended up in the report. What are we talking about there? That sounds like a John DeLisi question.
Well, certainly we interviewed a number of FAA personnel, and you're asking about what the thoughts of a person who provided that information to us are. We assimilated all of that, and we've made a number of recommendations to the FAA to improve the approval process, providing better information and better time. That's what we felt the most important takeaway from those interviews were.
Okay, thank you very much. No further questions.
Any further questions from any of the other members? In that case, we will proceed to deliberations. Managing Director Zoller, please read the proposed conclusions and findings.
As a result of this accident, staff proposes 17 findings. Number one, although the co-pilot made the required 0.8 Mach call out at the correct point in the flight, he incorrectly unlocked the feather immediately afterward instead of waiting until SpaceShipTwo reached the required speed of 1.4 Mach. 2, the unlocking of the feather during the transonic region resulted in uncommanded feather operation because the external aerodynamic loads on the feather flap assembly were greater than the capability of the feather actuators to hold the assembly in the unfeathered position with the locks disengaged. 3, the co-pilot was experiencing high workload as a result of recalling tasks from memory while performing under time pressure and with vibration and loads that he had not recently experienced, which increased the opportunity for errors. 4, the pilot and co-pilot were properly certificated and qualified. Fatigue and medical and pathological issues were not factors in this accident. The recovered vehicle components showed no evidence of any pre-impact structural, system, or rocket motor failures. 5, SpaceShipTwo's instantaneous impact point on the day of the accident was consistent with the requirements of 14 Code of Federal Regulations, Section 437.57, Operating Area Containment. 6. Although Scaled Composites System Safety Analysis, SSA, correctly identified that uncommanded feather operation would be catastrophic during the boost phase of flight, and that multiple independent system failures had to occur to result in this hazard, the SSA process was inadequate because it resulted in an analysis that failed to 1, identify that a single human error could lead to unintended feather operation during the boost phase, and 2, consider the need to more rigorously verify and validate the effectiveness of the planned mitigation measures. 7. By not considering human error as a potential cause of uncommanded feather extension on the SpaceShipTwo vehicle, Scaled Composites missed opportunities to identify the design and/or operational requirements that could have mitigated the consequences of human error during a high workload phase of flight. 8. Scaled Composites did not ensure that the accident pilots and other SpaceShipTwo test pilots adequately understood the risks of unlocking the feather early. 9. Human factors should be emphasized in the design, operational procedures, hazard analysis, and flight crew simulator training for a commercial space vehicle to reduce the possibility that human error during operations could lead to a catastrophic event. 10. The Federal Aviation Administration Office of Commercial Space Transportation's evaluations of Scaled Composites' initial and first renewal of the SpaceShipTwo experimental permit application were deficient because the evaluations failed to recognize that Scaled Composites' hazard analysis did not meet regulatory requirements to identify hazards caused by human error. 11. The lack of direct communications between Federal Aviation Administration Office of Commercial Space Transportation technical staff and Scaled Composites technical staff, the pressure to approve experimental permit applications within a 120-day review period, and the lack of a defined line between public safety and mission safety assurance interfered with the Federal Aviation Administration's ability to thoroughly evaluate the SpaceShipTwo experimental permit applications. 12. The Federal Aviation Administration Office of Commercial Space Transportation did not ensure that Scaled Composites was in compliance with the mitigations cited in the waiver from regulatory requirements or determine whether those mitigations would adequately address human errors with catastrophic consequences. 13. The experimental permit pre-application consultation process would be more effective if it were to begin during a commercial space vehicle's design phase so that concerns can be resolved before a commercial space vehicle is developed and manufactured and potential catastrophic hazards resulting from human error can be identified early. 14. The effectiveness of the Federal Aviation Administration Office of Commercial Space Transportation's inspection process would be improved if inspectors were assigned to commercial space operators rather than individual commercial space launch operations, because the inspectors could become more familiar with the operators' training and procedures and could identify ways to enhance safety. 15. A database of lessons learned from commercial space mishap investigations would provide mutual benefits to public safety and industry promotion and would thus be consistent with the Federal Aviation Administration's mission and authority. 16. Scaled Composites and local emergency response officials could improve their emergency readiness for future test flights by making better use of available helicopter assets. And 17. Additional parachute training and procedures would have better prepared Scaled Composites test pilots for emergency situations.
Thank you, Mr. Zoller. Is there a motion to adopt the findings as proposed?
So moved.
Second? Any discussion? The motion has been seconded. All those in favor signal with a hand and say aye. Aye. The vote is 4-0 in favor of adopting the findings as proposed. We will move on now to the probable cause. Managing Director Zoller, please read the proposed probable cause.
Staff proposes the following probable cause. The National Transportation Safety Board determines that the probable cause of this accident was the co-pilot's premature unlocking of the SpaceShipTwo, SS2, feather system as a result of time pressure and vibration and loads that he had not recently experienced, which led to the uncommanded extension of the feather during the transonic region and resulted in the aerodynamic overload and in-flight breakup of the SS2 vehicle. Contributing to the accident was Scaled Composites' failure to consider the possibility that the effects of a single human error could cause the feather to extend uncommanded and fully inform pilots about the risk of unlocking the feather system early.
Thank you. I know there have been several possible amendments floating around, and I've got one myself. But if anybody else has any they would like to read in first, I'll go in order. I think it's easier to, before we make a motion, to look at what all is on the table and discuss it in toto. So anybody else have any? I think everybody has seen the proposal that I've put out. We've handed it out, and I would propose to read it, and then see if there's a motion, and then commence discussion on it. My proposed probable cause would be: the National Transportation Safety Board determines that the probable cause of this accident was Scaled Composites' failure to protect against the possibility that a single human error in an environment involving time pressure, vibration, and unusual G-loads could result in premature unlocking of the feather in SpaceShipTwo at a time when such action could result in uncommanded feather extension and cause aerodynamic overload and in-flight breakup of the vehicle. So I would like to, I think you have what I just read, except in the next to the last line, would is changed to could. But other than that, I believe you have what I just read. So I'm going to make the motion to amend the probable cause accordingly and see if there's a second.
I'll second for discussion.
Okay, I'd like to have discussion from both the board and the staff to see how everyone feels about it. The motion's been seconded, so let's start with staff. Does staff have a position on the proposed amendment?
I've got extra copies if anybody needs them. You'll have them.
Thank you, Chairman. We certainly appreciate an opportunity to participate in this discussion. One comment from staff on this version, it does not include the action of the co-pilot. It perhaps reads more like a finding from an audit or a design review as opposed to this accident investigation. As accident investigators, we certainly looked at the data. The video was compelling and helped propel us into the findings of this investigation. So this particular version leaves out the phrase, the co-pilot's premature unlocking of the feather system.
Thank you for that comment, and actually that was intentional because the intention was to go for the but-for cause, if you will. But I would entertain any friendly amendments if you would like to revise that accordingly. If you have any suggested language, I'd be happy to entertain that. Do you have any thoughts in that regard? While you're thinking about it, let me see if the other members have any discussion regarding this probable cause. Please. Member Sumwalt.
Well, thank you. I saw this at basically 9:15 this morning. I notified your assistant that yes, I could support it, but in the intervening time, and by the way, I do like a lot of what's there, but my thoughts are exactly along the lines of Mr. DeLacy's. Really, just going back through accident causation theory, usually there are two pathways. There's a latent pathway and there's an active pathway, and so this discusses the latent pathway. This does not say what the initiating event was. What is read here was in the system for PF1, for PF2, and PF3, and there was no accident. So what is it that made PF4 different? And it was that active failure of the co-pilot. So I think frankly it is incomplete unless we add in that triggering mechanism. I'm very pleased, as my colleagues know and staff knows, I circulated a probable cause yesterday where I felt like scaled should be moved up to the probable cause and not just a contributing factor. And I believe that's accurate. But again, I think one thing that's missing here is that. And I think that we can get there. And I was playing with some wording, and it gets very redundant from what's already said. But we could take what's there, what's just been read, and then some language that staff, well, and I'm just not going to quite propose it yet, but just throw it out there. After what has been read, something along this set the stage for the co-pilot's premature unlocking of the feather system, which resulted in the aerodynamic overload and in-flight breakup of the vehicle. The thing I don't like about it is that the wording starts getting redundant from what's already said, but it does add in that what we just read, what the chairman just read, set the stage for the allowing of the co-pilot's error.
Thank you, and I appreciate those concerns. I'm going to suggest, why don't we take a 20-minute break and let staff play with it, wordsmith with it, and then we can resume in 20 minutes, which would be, I'm trying to figure out, I have trouble reading that clock. 11, let's resume at 11:30 and see what staff can come up with. And remember, Sumwalt, thank you for those comments, and thank you for your suggestions on this one as we read it as well. Anybody have any comments now before we break? Okay, let's take a brief break, and we will resume at 11:30. By way of a progress report, we're in the final stages of getting a revision of the probable cause, so we'll be resuming in a few minutes. Thank you. Could we take our seats? We're going to start in a couple minutes. We are now back in session. I want to thank the staff for revisiting the probable cause, but before we get to that, I understand there's an issue regarding one of the findings, so please let me turn that over to the staff.
Thank you, Chairman. We did notice the need for a technical correction to conclusion number 4. We have the phrase pre-impact structural damage in that conclusion. We'd like to technically correct that to now say the recovered vehicle components showed no evidence of any structural system or rocket motor failures before the in-flight breakup.
Okay, so would you read that again, the exact wording of finding the last sentence of finding number 4?
Finding number 4, the second sentence would now read, the recovered vehicle components showed no evidence of any structural system or rocket motor failures before the in-flight breakup.
Okay, thank you. Since we've already voted on the findings, that this would take a motion from one of the members to revise finding number 4 as suggested.
So move. I find that, I recommend that finding 4 be amended to read as follows. The pilot and co-pilot were properly certified and qualified. Fatigue and medical pathological issues were not factors in this accident. The recovered system vehicle component showed no evidence of any structural system or rocket motor failures before the in-flight breakup. And that would be my motion.
Okay, any seconds on that motion? Any discussion from the members? Discussion from staff? Motion to amend finding number 4 has been seconded. All those in favor signal with a hand and say aye. Aye. The vote is 4-0 in favor of adopting finding number 4 as amended. Now we need to re-vote for adopting the findings in their completion. So is there a motion to adopt the findings, as the total findings as amended? Second, okay. The motion to adopt the findings as amended has been seconded. All those in favor signal with a hand and say aye. Aye. The vote is 4-0 in favor of adopting the findings as amended. Now let's turn over to the probable cause. Staff has handed me something that they have prepared as a revision to the probable cause. I would be willing to rescind my motion and make a new motion. Maybe that's the cleanest way to do it. And my new motion would be to accept the probable cause as the staff has revised it, and I will read that. The National Transportation Safety Board determines that the probable cause of this accident was Scale Composites' failure to consider and protect against the possibility that a single human error could result in a catastrophic hazard to the SpaceShipTwo vehicle. This failure set the stage for the co-pilot's premature unlocking of the feather system as a result of time pressure and vibration and loads that he had not recently experienced, which led to uncommanded feather extension and the subsequent aerodynamic overload and in-flight breakup of the vehicle. So I move to adopt that as the probable cause. Any second on that motion? Second. Any discussion from the members? Any discussion from the staff? Okay, the motion has been seconded. All those in favor signal with a hand and say aye. Aye. The vote is 4-0 in favor of adopting the probable cause as amended. Managing Director Zoller, please read the proposed recommendations.
As a result of this accident, staff proposes 10 new safety recommendations. There are 8 to the Federal Aviation Administration. 1, in collaboration with the Commercial Spaceflight Federation, develop and issue human factors guidance for operators to use throughout the design and operation of a crewed vehicle. The guidance should address, but not be limited to, the human factor issues identified during the SpaceShipTwo accident investigation. Number 2, implement steps in your evaluation of experimental permit applications to ensure that applicants have 1, identified single flight crew tasks that, if performed incorrectly or at the wrong time, could result in a catastrophic hazard. 2, assessed the reasonableness, including human factor considerations, of the proposed mitigations to prevent errors that could result from performing those tasks, and 3, fully documented the rationale used to justify related assumptions in the hazard analysis required by 14 Code of Federal Regulations, Section 437.55. Number 3, develop a process to determine whether an experimental permit applicant has demonstrated the adequacy of existing mitigations to ensure public health and safety, as well as safety of property, before granting a waiver from the human error hazard analysis requirements of 14 Code of Federal Regulations, Section 437.55. Number 4, develop and implement procedures and guidance for confirming that commercial space operators are implementing the mitigations identified in a safety-related waiver of federal regulations, and work with the operators to determine the effectiveness of those mitigations that correspond to hazards contributing to catastrophic outcomes. Number 5, develop and issue guidance for experimental permit applicants that 1, includes the information in Advisory Circular 413-1 license application procedures, and 2, encourages commercial space vehicle manufacturers to begin the consultation process with the Office of Commercial Space Transportation during a vehicle's design phase. Number 6, develop and implement a program for Office of Commercial Space Transportation inspectors that aligns them with individual operators applying for an experimental permit or a launch license to ensure that the inspectors have adequate time to become familiar with the technical, operational, training, and management controls that they will inspect. Number 7, direct Office of Commercial Space Transportation, AST, management to work with AST technical staff to 1, develop clearer policies, practices, and procedures that allow direct communications between staff and applicants, 2, provide clearer guidance on evaluating commercial space transportation permits, waivers, and licenses, and 3, better define the line between the information needed to ensure public safety and the information pertaining more broadly to ensuring mission success. And 8, in collaboration with the commercial space flight industry, continue work to implement a database of lessons learned from commercial space mishap investigations and encourage commercial space industry members to voluntarily submit lessons learned. And there are 2 recommendations to the Commercial Space Flight Federation. Advise commercial space operators to work with local emergency response partners to revise emergency response procedures and planning to ensure that helicopter and other resources are appropriately deployed during flights. And the last recommendation to them, work with the Federal Aviation Administration to develop and issue human factors guidance for operators to use throughout the design and operation of a crewed vehicle. The guidance should address, but not be limited to, the human factor issues identified during the SpaceShipTwo accident investigation.
Thank you, Mr. Zoller. Is there a motion to adopt the recommendations as proposed? Second? The motion has been seconded. All those in favor signal with a hand and say aye. Aye. The vote is 4-0 in favor of adopting the recommendations as proposed. Is there a motion to adopt the report as revised? Second? The motion to adopt the report as revised has been seconded. All those in favor signal with a hand and say aye. Aye. The vote is 4-0 in favor of adopting the report as revised. The report has therefore been adopted. Do any board members wish to file concurring or dissenting statement? Hearing none, is there any further discussion? In closing, I would like to recognize the hard work of NTSB staff in producing this report in record time, I would add, and thank my fellow board members for their very thoughtful and extensive participation in this process. Throughout this meeting, we discussed various human factors issues that were known from previous transportation accident experience, but that were not thoroughly addressed in this test flight by Scale Composites. We also examined how certain hazard analysis requirements were waived by the FAA. In the big picture, commercial space travel stands on the verge of becoming reality. Some of you may remember the iconic scene in the film 2001: A Space Odyssey. in which a Pan Am passenger shuttle approaches a space station. In 1968, Pan Am even started a waiting list of people interested in taking a commercial space flight. That list grew to a total of 93,000 applicants. Today, the vision of commercial space travel is close to fulfillment. Hundreds of people whose only qualification for spaceflight is their ability to purchase a ticket await the opportunity to go into space on commercial space launches. But for such flights to proceed safely, commercial space transportation must continue to evolve and mature. The success of commercial space travel depends on the safety of commercial space travel at the level of every operator and every crew. The recommendations to the FAA and to the commercial space industry that we approve today are early steps in this commercial space safety journey. If acted upon, they will help ensure that the FAA's evaluation of experimental permit and license applications is more robust, and that the FAA demands and ensures the mitigation of risks to the public and property if and when it waives requirements. In commercial space transportation, manufacturers are pursuing widely varying approaches to find the best technological solutions. Today's recommendations, if heeded, will enhance the FAA's ability to provide oversight that more fully recognizes each operator's specific and variable approach. These recommendations will also result in stronger guidance regarding human factors in the design and operation of commercial space vehicles, enhanced collaboration between FAA technical staff and operators, and the collaborative sharing of safety lessons in commercial spaceflight through a database that is now under development at the FAA. Such a database will allow the commercial space sector to benefit from a long-standing principle in commercial aviation, namely that anybody's accident is everybody's accident. Operators can and do compete on many levels, whether in commercial aviation or in commercial space transportation, but when it comes to safety, they must cooperate and collaborate with each other and with the FAA. Thank you for your attention. We stand adjourned.